Hello. Uh, Now we can see when you ask that question to AI, it will tell you why you don't need to memorize all the digits. Thank you for your question. Jono 3379. Thank you for your question. Hello. CJO. Hello. This is a new physics project. Hello. This is a new physics project. It's a new research project. According to this study, there are issues with the relativistic view of the universe. I have given links, a few video links in the description. There is the mass energy. According to this study, mass and energy are not equivalent, or mass and energy are different entities. This can be experimentally validated through the study of spent nuclear fuel. When you study the changes associated with the spent nuclear fuel, there are many anomalies associated with the spent nuclear fuel. There are a list of a large number of changes. I hope you know what is spent nuclear fuel. Spent nuclear fuel means the fuel pellets collected from the radioactive reactor. That is, once it's exhausted, then they will engineers collect the fuel pellets, and they will allow it to cool in a water pool. So when you closely observe this spent nuclear fuel, there are many changes, structural and physical changes in the spent nuclear fuel that remains unexplained or poorly explained with the current framework. There are no proper explanation for these phenomena. If you would like to know what are the anomalies, in the description, the video description, I have provided a few video links that exclusively discuss about what are the anomalies. So, according to my research, mass and energy are different entities. The release of energy associated with a mass defect is not because of the conversion of mass into energy, as Einstein suggests in special relativity. In fact, the release of energy associated with the mass defect is because of a change in the state of matter. That is, when a nuclear fission or fusion happens, or in a particle collider accelerator, the busy mass, for example, in a fusion reaction, when the hydrogen isotopes fused together, a slight mass defect there is a mass defect. So these are baryonic matter, protons, neutrons are baryonic matter. But when this fuse, a slight mass defect happens. So hello. This baryon, according to this research, the baryonic matter converts into a non-baryonic matter form. So this baryonic matter is extremely dense, very dense nuclear density matter, baryonic matter. When it fuses, the mass defect happens. That mass defect is converted into non-baryonic form of matter, but mass is conserved. Matter is not lost. Matter is not directly converted into energy, as Einstein suggests in special relativity. In fact, the baryonic matter is converted into non-baryonic state of matter. That is a very thin form of matter. So when this happens, it explode. It explode, just like how chemical explosion happens. But the ratio, the expansion ratio is very high. That is, for example, for your understanding, I tell you an example. For example, a TNT. We know a TNT is a very highly explosive material. In a TNT, a 1 gram of TNT, when it explodes, when it reacts with oxygen, it in a say 1/10 second, it becomes 10 cubic feet of superheat gas. So this is expansion. So a small amount of mass, chemical substance, in a fraction of a second, it becomes many many cubic feet of superheated gas. That is a mechanism of the chemical explosion. But according to my study, this is applicable for nuclear reaction also. So the mass defect, the nuclear mass defect is converted into a super thin form of matter. The baryonic matter is converted into a non-baryonic form of matter. So that is the my discovery. So it has a huge significance in the understanding of the universe, because mass defect is a universal phenomenon. Every active star, our sun, every stars, every supernova explosions, every neutron star collisions, merger, and probably there may be other unknown process in the universe. This all creates a mass defects on a very large scale, cosmic scale mass defect. So once we realize that the baryonic matter is converted into a non-baryonic matter, that means space is filled with this type of matter. So this I can call is a modern ether. Ether concept is a very ancient concept. Then Michelson-Morley experiment, the interferometer experiment, unable to detect such a matter. So currently, scientific community almost completely disregarded this concept, and Einstein developed relativity based on the one of the foundation pillar of Einstein theory is the non-existent of, or the null result of the Michelson-Morley experiment. So then based on that, Einstein proposed that light has a constant speed. Hello. So, in fact, based on my studies, a space-filling substance indeed exists, but Michelson-Morley type experiment cannot detect it, because as a form of matter, this space-filling, this type of matter will be gravitationally bound to massive bodies. So Earth has every massive body gravitationally attract this type of matter, and it creates a density gradient around the body, the mass. So every massive body, Earth, planets, stars, supernova, neutron stars, or black holes, all these objects maintains a dense region around it. So when a body moves, for example, when Earth moves through space, this atmosphere, this atmosphere, just like the atmospheric air, the surrounding space also co-moves with the object. So it creates a local region. It creates a local region. So when you do an experiment in this local region, when you do any this kind of velocity difference between perpendicular angle, so since it's a local region, we are not able to detect any either event like phenomena. So Michelson-Morley type experiment cannot help to detect this space-filling substance. Block how big is the universe? In fact, based on my understanding, universe does not have a finite volume, a definite volume or a size. Perhaps it is infinite. We cannot calculate or assess its size. Because most of the current theories are based around some concepts like constancy of light speed, non-existence of space-filling substance, and space-time curvature. These all are, according to my research, are not. It's far from the truth. The Einstein's curved space-time. Einstein suggested the curved space-time based on the idea that gravitational density of light, starlight bending, precession of the perihelion Mercury's orbit, and gravitational time dilation, all this. But once you understand the existence of, once you accept or once we clarify the existence of a space-filling substance, it can provide alternative explanation for all these phenomena, a better explanation for all phenomena which we currently study and explore through the lens of special and general relativity. For example, this Lorentz transformation effects, time dilation, increasing mass of a moving body, length contraction, starlight bending, gravitational lensing, precession of the perihelion Mercury's orbit, and all phenomena, gravitational time redshift, blue shift, Shapiro effect, gravity probe experiment, all these phenomena can be explained in a better way, more accurate way with this space-filling substance. The important thing is that mass defect. Mass defect is in my opinion, mass defect is one of the least explored area of study, area of research. What happens to mass defect? According to current understanding, that is proposed by Einstein, mass and energy are equivalent. Mass can be converted to energy, but that is not the case. That is not true. Mass and energy are entirely two different entities. One cannot be converted into another. There is an intermediate mechanism. According to special relativity, when a nuclear fission, nuclear reaction happens, or any high energy event happens, the missing mass is directly converted into energy. However, my research says that according to this new physics research says that there is an intermediate mechanism. In special relativity, no intermediate mechanism. Mass defect is directly converted into energy. However, in this new research, there is an intermediate mechanism. That is an explosion, exploding mass defect hypothesis, I say. So when a fission or fusion happens, the missing mass creates a powerful explosion. It's an impulsive release of energy, instantaneous, impulsive release of energy. So there is an intermediate mechanism between a mass defect and energy release. Most of the energy associated with a reaction, chemical nuclear reaction, is even a particle collision experiment. Most of the energy associated with a mass defect release of the kinetic energy of the reaction products. Thank you very much. So there is an intermediate mechanism between a mass defect and a fission reaction or fusion reaction and the release of energy. As I said, uh, uh, thank you very much. Yeah, you can check anywhere. Down also you can check. You don't need to come. എടാ എല്ലാം സെയിമാടാ ഇവർ now I have shared a ebook here in the you can find it in the live down now the store. There is a test for general relativity. Relativity. Gravity is the curvature of space-time by mass and energy. So, according to Einstein's general relativity, gravity is the curvature of space-time. Gravity is the curvature of space-time. If that is the case, this is a test with the collocated the title is the book title is A Falsifiable Test of General Relativity, the collocated. Close it. Okay, so I have given a book in the store. So I have given a book link here. So the book is the book title is A Falsifiable Test of General Relativity, the Collocated Clock Experiment. This experiment, it's a test for general relativity. If according to Einstein's, as I said earlier, general relativity says that gravity is a curvature of space-time by mass and energy. If that is the case, the experiment is about it consists of two types of clocks. One is atomic clock and a nuclear clock. If Einstein's curved space-time is correct, the any clock, regardless of its internal mechanism, whether mechanical clock, uh, electronic clock, or atomic clock, nuclear clock, what the clock it is, it should be affected equally in any. So the idea is that we keep one atomic clock and a nuclear clock at a certain altitude. Then we'll measure the clock frequency. Then we raise the altitude at the same altitude. If the ratio difference, the ratio between the both clock are remain the same, that validate Einstein's curved space-time. Uh, uh, because curved space-time should equally equally influence any type of clock, regardless of its internal mechanism. However, according to my research, as I said, space is not empty but filled with a form of matter created by mass defects throughout the universe. So it creates a density gradient around a massive body. So according to this research, the gravitational time dilation is because of uh, the influence of this dense space filling region. One second, I'm going to change this. It just feels very hot, so I feel I'll change it shut. Sorry for interruption. That shot was a little uncomfort. So this book, this experiment has only two outcome. One is the confirmation of it will confirm relativity, because if you find that uh, uh, the both clock equally is the ratio it remains same, then gravity, special relativity will get validated. And if it is not, it will it will definitely it will challenge the curved space-time concept. So if you are interested, you can purchase the book. It's an ebook format. Thank you for your interest. Yes, hello, Henry. Yes, I agree with that statement. In fact, Einstein's, I also con- think that I convinced that Einstein is more, Newton is smarter than Einstein. Yes, Einstein's theories are, but I respect Einstein because of his idea that small amount of mass can release a large amount of energy. That I admire that that is the original thinking, but the explanation he gave is not accurate. Mass and energy are two different things, but a small amount of mass can release a vast amount of energy. In that case, Einstein was correct, but his explanation for the mass energy conversion was not correct. And also, uh, all phenomena which we currently explain or study through the lens of special and general relativity can be can be explained in a better way with this new framework. Hello. Yes. Okay. Thank you very much. Yeah. I think definitely he was a genius. No doubt about that. But his assumptions are some assumptions are correct, but many of his assumptions was not correct, such as the constants of light speed. Light speed is not a constant. Light speed varies across the universe. According to this research, light speed is not a universal constant. It varies across the universe. So that is starlight bending, gravitational lensing, all that is because of the refraction of light. Uh, uh, I have a degree. I recently attended a conference, international conference in Delhi, where this was my paper about the mass defect and release of energy. Hopefully I am soon I am attending a conference from UK IOP conference, and I am preparing my research article for peer review. That is happening now. Okay. Thank you for nice to meet you. You are from? In fact, it's a very impactful. Okay, 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 great. Okay. Anyway, uh, uh, I am from India. Now, at present, I am in Bangalore. Bangalore. So, study is a. I strongly believe that we are going to witness a major revolution in physics. I actually say I am very happy to be alive now, this time, this time frame, because of the AI. The AI is helping me a lot. I can evaluate, I can scrutinize, brainstorm, all that. So AI helping me very much. So I think that I sincerely believe that very soon we are going to witness a major revolution in the understanding of the universe, how things work. In fact, there is no curved space-time. Curved space-time is a wrong concept. That what the book I pinned here that explains the book title, a falsifiable test of general relativity. That test, in fact, can uh, it yes, that is a very interesting question. In fact, as I said before, every mass defect is to explain, to tell about, to discuss about that. I have to explain something, that I have to discuss something. Then only I can make my point. That is, first thing, space is not empty formation. Michelson-Morley experiment, that such a kind of Michelson-Morley type experiment cannot detect this space-filling substance, because every massive body has a dense region around it. So when a body moves through space, this dense region co-moves with this. It creates a local region. So we are sitting inside a local region. There no relative motion between Earth and this region. So this is co-moves with the main body. So any in Michelson-Morley type experiment cannot detect it, but there are other ways to detect variations. For example, that is a gravitational time dilation, wave nature of matter. Uh, and many other phenomena, this Lorentz transformation effect, all these are evidence for the space-filling substance. All these phenomena, which we currently study and explore through the lens of special relativity and general relativity, can be reinterpreted successfully with this space substance. So space-filling substance is a reality. But the important point is that space-filling substance is not one type. There may be, I believe that there may be many different types of space-filling substance, particles of space-filling substances. When a nuclear reaction happens, there is a missing mass from the baryonic state of matter. So that's what I explained some time back. When a fission or fusion happens, the nuclear particles bond or split the mass defect. So this mass defect is a baryonic matter defect. The mass defect is happens from the baryonic state of matter. So when this happens, according to this research, the missing mass it creates a powerful explosion. It volumetrically expands and explodes. So baryonic matter becomes a non-baryonic form of matter. Mass is mass is not lost, mass is conserved. So it creates a powerful explosion. Since mass defect is a universal phenomenon, everywhere it's happening throughout the universe, space is filled with this type of substance. So, space is not empty formation. So, yeah, I sincerely believe that there may be different types of particles with different properties, different sizes. Uh, uh, so, yes. Okay. Yes, yes. Most of the days I'll come online. Where are you from? Okay. Okay. Right. Okay, right. We'll see you later. See you tomorrow.